Hi there. I'm John Slattery. You might recognize me from the wildly successful television show Mad Men, on which I play the incredibly charismatic Roger Sterling. Or a host of other giant Hollywood blockbusters where I've been romantically linked with a bevy of Hollywood beauties. You might ask yourself, why the hell is this guy talking to a room full of computer nerds? That's a fair question. All I can say by way of an answer is that if Steve Duplessie ever comes to you and says he has incriminating photographs from an event that took place years ago, one which you were barely involved in, I suggest you listen to what he has to say. So without further ado, I'd like to welcome my good friend and total blackmailer, Steve Duplessie.
Ladies, careful. Huh? That's it for Vegas? All right, bye, ladies. That's much better. Thank you. My new analysts. Good morning. I mean, this is the hangover session. We had to pump it up just a little bit. How's everybody feeling? Shitty? Tell me the truth. All right. Well, thanks for waking up. I do appreciate it. I'm going to do something I don't normally do. I'm going to actually compliment EMC. And I mean this from the bottom of my heart. What a pretty spectacular event, eh? I do this for a living, which means I have a pathetic life. You're just enjoying this, but... So I do a lot of these things, and they're really painful most of the time and terrible, but this was, quite frankly, spectacular. So I do give them a lot of credit. These are really hard to do. They're hard to sit in. They're really hard to do. And if anything, I guess my only negative critique of this event, if I could have one, is that there's actually too much stuff. There's 73 different really interesting sessions going on at any given time, and so I don't know how you mitigate that or fix that, but it was pretty impressive. Second compliment I would like to make to my friends here at EMC is I have the honor of being the first ever non-EMC employee to speak at an EMC World, apparently. And I don't know if you... This may not be a big deal to you. If you've seen me before, you realize that that's a terrible risk for a company to take. Now, the good news is that I love them, and I love everybody, so it's not a problem at all. But I do commend them because EMC World is about education, by and large. And I give them a lot of credit because they really didn't ever once try and force me to say something they wanted me to say. And that's very unlike EMC. Very unlike them. Control everything. So I give them kudos for the candor. So this morning, we're going to talk about, I would say, what is arguably outside of the word cloud and outside of the word virtualization, the most ridiculously hyped, misunderstood construct going on in our industry right now. And I love things like that because I'm a really simple guy. And my job in life, if you can call it a job, is to try and take industry-inflated, self-created confusion and break it down into what really matters and what should you care about, what shouldn't you care about, and go on from there. So, as always, if you have a question, ask. It's just a small room. There are no stupid questions, there are only stupid people. Since 1837, when the first computer was invented, or whenever it was, when we were children, we've all seen the magic pyramid. Fundamentally, for 60 years of commercial and/or scientific computing, every computer works the exact same way. Every year, the bits and pieces get faster and cheaper, and we apply Moore's law and all these other things, but fundamentally, every computer works the exact same way. At some point, we need to execute a command. That happens at a processor. In order to execute a command, we have to execute on a data set. In order for that to occur, the data, irrespective of where it exists, has to move from wherever it lives up to that processor. Fundamental 101 kind of stuff. The higher you move up the stack, the faster things are, the more expensive things are. That's not going to change. It has not changed. It will not change. So in this magic pyramid, at the top, the most expensive asset that we have is the processor itself. Then we move down and we know all the stages, right? We have memory and we have disk and we have tape and we have cloud. Doesn't matter what you're interjecting there. The flash path happens the exact same way. Flash, I could probably end this presentation in 3 minutes. Flash is going to be everywhere. It's not one place. It's not one thing. Right now, as an industry, we love to argue about mine is bigger than yours. Buy mine, it's better. Mine's faster. Mine's cooler. Mine goes here. This is where you should do something. Flash, like any of these technologies, are not, much to industry's dismay, binary decisions. The answer is yes. Flash exists everywhere, and it will exist everywhere. And just like historical computing paradigms, the closer or the higher up we get on implementing our flash-oriented high-speed technologies towards that processor, the more expensive it's going to be. The smaller from a unit of measure, irrespective of what that unit is, right? Capacity, for example, gets smaller and tighter as we move up there, and the unit of measure gets more and more expensive as we go. But because that nifty graphic says so, flash is going to exist and does exist already today at every single layer of our computing stack. See, I got to the point. Flash will be everywhere, so stop worrying about it. As an industry, we love to take things that already exist. Typically, we like to create a brand new acronym, and then we confuse everybody by charging twice as much money as what existed before. And then we argue about it for 2 years. You have to do it my way. You have to do this. You know, ILM, Information Lifecycle Management. Wasn't that HSM 40 years ago? Isn't it the same exact stuff? Virtualization. It's brand new. Revolutionized the world. And we have LPARs 45 years ago in mainframes. Right? None of this stuff is new. The only thing that changes in our industry, or in the computer business by and large, are the acronyms. Right? That's really all the stuff that changes. So my kind of overriding point is, even though this is all confusing and we're going to go through some of the bits and bytes and why put something here versus there, right, is to try and demystify this whole construct from the perspective of there is, you know, we fight and we worry about the wrong things. So we'll try and stop doing that, sorry. Flash is solid state storage. We have had solid state storage forever. We've had it forever. It's not new. Just a new implementation of technology to the same problem that has existed ad infinitum. This is the only things that anybody should worry about when we're mentally discussing with ourselves or others what is the appropriate implementation strategy for flash moving forward in our world. There are two fundamental elements. We'll talk about both. Is it fixed or is it a cache? I.e., is it a device? Is it a LUN? Is it a target? Is it just something there that we see physically that we as humans decide what goes on it? Or is it a cache that makes everything behind it, theoretically, faster? Is it its own, or is it a shared asset? Second is, are we going to share that asset amongst the multiple processors that could or should be using it, or is it going to be direct attached? Those are really the only primary considerations that I suggest you have. And we'll talk about that. So fixed versus a cache. We've had caches at every layer of that pyramid pretty much forever. The processor that Intel puts out has level 2 caches built right into it. Matter of fact, as we move down and we go off the processor to the PCIe bus, in the next iteration of the processor, the PCIe bus itself is built right into the core. It's not even external anymore moving forward. So theoretically, flash will exist right at the core, just like it does today as a level 2 cache, something like that. So the way that now, I'm not a fan of a fixed device. Unless, and here's why, right? If everything is a fixed device, the human being is the fatal flaw. The human being has to decide what goes on that device. You are the optimization protocol and algorithm. You decide what goes on there. Now, don't get me wrong. There are certain very, very small as an overall percentage, certain applications that we have where we know we have to have something on the fastest thing in the world. We have to have this executable data set on the fastest thing in the world all the time, no matter what. And if you know that, then that's great. But otherwise, the machine is smarter than you, and I mean that respectfully. We're weird as an IT society. We're weird. We don't trust the machine. We are terrible generally at adopting automation in IT. Terrible, because we don't trust the machine. Now, over time, we're always proven wrong. Right? Some of you that are as old as me remember the genesis of the RAID business 25 years ago or something. And RAID, until RAID happened, there's no such thing as striping. We didn't move data around. We didn't virtualize disks. We had physical disks, raw devices. How many of us had a DBA that said, you're never putting my database on anything but a raw device, because we didn't trust it. We feel like somehow we're in control if we can see something. Now, today, or another example, just in terms of how we deal with automation as people, it wasn't very long ago a sysadmin, when they put up an application, had to physically allocate main memory, had to do mental math, physically allocate main memory to that application for it to execute. Had to think about page and swap file size. You decided what that happened. And guess what? You were wrong sometimes. Sometimes you were wrong. Stuff didn't run perfectly. Now no one does that because the operating system says, I got that. I will figure that out in real time. When when you created RAID arrays, you did the math and said, I'm going to pick this chunk size, this stripe size. No one does that anymore because you're not as smart as the controller. And, oh, by the way, that is low-level, tactical, error-prone, no strategic value to you or your organization, but a heck of a lot of tactical risk associated with it. So a cache, in my estimation, is a means that you've already implemented today, whether you know it or not. It's a means of letting the machine optimize. The difference between now, and you buy a disk drive, even if it's an array, the disk drive itself already has cache. It's got flash built onto it. Your tape drive has cache today. Your server has cache. Right? They all operate completely discretely from one another, and that's what's going to have to change ultimately over there. But so I guess my point on at some point was you can't worry about that. You got to let the machine do what it was intended to do. So as a general rule, I like cache because cache represents, the difference in caches is who's got a better algorithm. You know what manual tiering is inside of an individual subsystem? It means you are the algorithm. You decide what goes on tier 1, tier 2, tier 3, tier 20. You decide that. And then you make that decision and you move that data, and then you hope like heck that nothing ever changes, because God knows in our world nothing ever changes. What? Every day you'd have to go back and retool and remove and take X off of Y and et cetera, et cetera. Until you get to the point where now you've got subsystems that actually do that for you, right? Inside that box, that subsystem itself does that for you, optimizes data placement. And now it's kind of hard to buy even the lowest end stuff does it for you. Anyway. There are two metrics that you need to concern yourself with in any of these discussions: performance and cost. Everything else is irrelevant. Those slide, and those are variable knobs based on whatever your particular requirements are. The most expensive and guaranteed highest performance implementation of Flash or anything is when you create a fixed object. It will always be the most expensive. It will always be the most poorly utilized, but it will always be guaranteed at a performance level. When you cache, you're saying, I can't afford everything to be fixed. Right? We could solve this whole problem if you had unlimited money. Just make everything Flash. Everything's the fastest thing you can buy. But since that's not realistic, you need to make deterministic decisions based on what is most important for you. The 80-20 rule, the 90-10 rule, whatever the case is. So if you cache, you can say, I can spend a little bit of money, comparatively, still expensive, but a little bit of money comparatively, to create intelligence on top of all of my data structures beneath it that are really cheap, comparatively, whether that's disk or tape or cloud or whatever the case may be. And so those are kind of the offset decisions. Cache works intelligently on everything beneath it. Fixed stuff doesn't. When it's fixed, you're the algorithm. So you better be a smart algorithm. Make sense? If you have an application that is an absolute known thing, and we're going to talk about examples of where fixed might be more applicable. In a perfect world, if the algorithm was perfect, you would never have a fixed device. You would only use cache in a perfect world because the algorithm itself is so smart, it guarantees that every I/O you do would come from that high performance, inexpensive, comparatively Flash-based stuff. World is not perfect. Some things require, right, that you can't take those hits. There are some applications that require, it's got to be the fastest thing, it's going to be in the PCI bus, and it's going to be guaranteed fixed. And I'm going to put 1 terabyte in there, and I'm going to spend $1 zillion, and that's just the way it is. Second decision, and this one's weird to me, because when you're in the nascent part of a market, even though the market, I would argue, is 1 million years old, but it seems brand new. There's 100 competitors. There's a lot of noise and buzz and misdirected information, et cetera. But it's funny to me because we spent the last 30 years, it's certainly in the storage world, connecting everything together. We've networked everything because that makes sense. Enter virtualization in the server world, and what does virtualization for the server world enable us to do? Good or bad, it enables mobility. So all of a sudden, we spent 30 years as a storage industry saying, hey, you got a whole bunch of different servers, let's get better utilization and access capabilities by networking our storage. Now we layer on virtualization, and the workloads that we're executing all of a sudden aren't sitting on just server 1 anymore. They're moving around. They have the capabilities to go to server 2, 3, 5, whatever. Now that mandates that we have network storage. Because moving a VMDK around is really cool if the data goes with it. Otherwise, it's just dumb, right? So it's sort of, we've now built our IT society of the future predicated on mobility. And mobility demands everything's connected to everything, somehow. I don't care if it's SAN or NAS or whatever. Everything's connected to everything. So it's interesting to me that the early players, certainly the early success stories in the flash market from a storage perspective are direct attached. It's counterintuitive. They plug into one machine, and that's it. So if that workload doesn't execute on that machine, you're shit out of luck, which is a technical term. Right? Okay. You get it. Fixed equals, it's just a LUN. It's an addressable target. You decide what goes on it, that's what stays there. Cache equals, it's variable. Transient. Cache is supposed to be smart, moves things in and out based on that. In a perfect world, everything would be solid state flash. World is not perfect. Share it or don't. Those are really the only kind of 4 variables in this whole discussion, I think, that matter. Okay. Simple math. I could buy a terabyte for 10 grand. Forget the numbers. This is just a relative element. And let's just say that terabyte, because every terabyte now is pretty fast. You know, this is another interesting kind of side note. 25 years ago, the storage business, when it became a business, EMC made it an independent decision, right? And before we even had an industry. But once that was a nascent business that just started and everyone was confused and banging their chests and saying, mine's better than theirs, don't buy mine, mine's bigger, mine's better, et cetera. Very reminiscent of exactly where we are in this particular day and age. But point being, for about the last 25 years, you know, in the beginning of the market, it was all about mine's faster and faster mattered. In the last 15 years, everything's been fast enough. As a general rule, no matter what you bought, it was pretty much fast enough. We didn't have I/O problems 5 years ago. We really haven't. Everything cycles back around. Enter virtualization again. All of a sudden, we're back to having I/O problems. Performance matters. You know, each one of your shops has gone through deployments where you've got, all right, everything works in the lab. It's terrific. We collapsed down 73 Exchange instances. We're virtualizing everything. We had stovepipe stuff, and now it's completely deregulated, decoupled, et cetera. And all of a sudden, we unload it into production, and things are slow. And we don't know why. Because the good news, bad news about virtualization, you know, McNeely said the network is the computer. Yeah, that's cool. How do you fix that? Where's the red light? In the old days, you could find the red light, see what was wrong, apply your brain to it, and fix the problem. Now it's really hard. So anyway, you buy a terabyte for 10,000 bucks of disks. It does a certain amount of work. In this example, I say 100,000 IOs. Right? Or you can spend a gazillion dollars, 10 times, 20 times, 100 times more money, and you can buy an all-flash array. You can buy that today, right? And it might do 10 times the workload, 20 times the workload. Those are decisions that you can make. Or there's some sort of hybrid that exists out there, and there are manifestations that already happen in your shop, right? You can buy an array and say, I'm going to cache certain stuff. I'm going to buy some, so I'm going to pay twice as much. Not 10 times as much. I'm going to pay twice as much. But if I can get 90% of the workload done, or in this case, you know, 4x the workload done, that's worth my investment along those lines. These are not binary decisions. Now, here's the interesting part. Because right now, this industry is saying, I could do 1 million. Mine does 1 million IOPS. That's really cool. How many people in here, show of hands, need something that can do 1 million IOPS? That's ridiculous. Right? No one does, the real world doesn't do that. Right? If you're only doing 487 I/O requests, any of those things would work for you. So we get caught up in the glitz and glamour of the coolest thing, and we really got to focus more on what is it I actually need to accomplish. Having 1 million IOP box is so cool, but if you're only doing 5,000 IOPS a second, who cares? Plug your iPad into it. Reason, besides the obvious common sense reason not to do that, this stuff is not going to get more expensive. Buy what you need. Satisfy your requirement in a little bit. This industry loves you to overbuy and scare you to death on what might happen. On what might happen. That's why forever we built these big stacks for the worst case scenario. I mean, oh my God, what if we get 1 billion hits and the site crashes because we're Victoria's Secret? We can't let that happen. So 99.9% of the time, we have way more stuff than we ever need. Terrible return on asset. Terrible. We've gotten better about not doing that, right? But that's why we buy virtualization stuff to begin with. Much better utilization rates. Much better asset return. Because Flash world, we're back 25 years again. People are trying to scare us into buying something we don't need. Because you don't do 1 million IOPS. You don't. I mean, some of you might, but as a general rule, you don't. if you can, final bullet there was trying to understand that in a perfect world, if you can optimize the existing infrastructure that you have and or new infrastructure, meaning spinning disks, spinning around, those are always going to be less expensive on a per unit of measure basis. So the trick is not, I mean, again, if money were no object, you could throw them all out and buy everything solid state. But money is an object. Therefore, optimizing that existing realistic footprint by adding some element of flash, in my opinion, cached flash that is shared throughout the infrastructure makes a heck of a lot more sense than throwing the baby out with the bathwater. All right. General rule, flash, NAND, you know, we've got all these little terms. People like to fight about various stuff, but as a general rule, unlike DRAM, the reason we have flash is it's non-volatile. Right? Doesn't mean it's protected. Does not mean it's protected. Does not mean it will not fail. It will. Right? But it is non-volatile as the primary difference, unlike DRAM. There are two basic kinds of NAND is the overall category thing. It doesn't even matter what it stands for. There's two wars right now the industry is fighting about, telling you that MLC is better than SLC. Or the other way around, actually. SLC is better. MLC's got a woof. You'll die. Your kids will be deformed if you use MLC. Don't. All bullshit. That's what it stands for. I didn't even know I put that there. Point is, doesn't matter. Doesn't matter, don't worry about it. Anybody that comes to you with that argument, just tell them to shut up. Because it will not matter. Do you know how your DRAMs are made now? No, because you don't care. I don't care. Right? Yeah, I know how they're made. I order it. I don't care. Right? How do they make power? I don't know. I don't care. Right? Same thing. We're in the early stage of a market, right? Bit heads love to get down and dirty in the weeds. And that's where we are in this space. These are I hear it every day. Well, our right level wear leveling technology and algorithm makes ours work 7 times. Shut up. It's no wonder you can't talk to girls. All right. So point on all that, and don't. If you actually care, you can ask a vendor about this stuff. My proposition to you is that you probably shouldn't care, because this stuff's moving so fast, and the people in this industry are so smart. They're just figuring the stuff out as we go. And so by the time you actually spend the energy and cycles to make a decision on X versus Y technology-oriented type of stuff, it's already going to be fixed somewhere else anyway. This stuff is moving real time, super, super fast. So don't concern yourself with that. I still say take it up a level, concern yourself with the higher level business abstracts. Excuse me. Right, let industry fight amongst industry. You go to another show and you can watch CTO from company A and CTO from company B swear at each other. That's awesome. Mine's better. Who cares? Seriously. Okay, so where can flash go? Well, this is where people, the industry caught on fire because of Fusion IO, who, I'm not going to poo-poo them too much, but I don't get it. You can stuff stuff in the server itself, direct attached, fixed in the server itself. Very expensive. You're the algorithm. You decide what goes on it. But if you need stuff to be in there that has to be the fastest that it can be, that's the best way to do it. Perfect way to do it. Going to cost you the most. Typically, I mean, it's not shared. So if your workload moves to another physical box, that thing's just a really expensive doormat. It's just sitting there being really expensive. And quite frankly, you know, it's the reason I don't like it as a general rule, unless you have some specific application that requires it, is it's sort of counterintuitive that you're going to spend $2,000 on the fastest server on the planet with 8 billion mega flaps and cores and stuff like that, and then pay $9 grand for a memory card to sit next to it that is not shareable. Right? So quadrupling the cost of your server makes kind of no sense to me, fundamentally. Also, those things are not protected. I talked about that earlier. It's not volatile, but if there's a failure, right? So you really you're going to have to mirror it. You got to buy 2. So not only is your server now 4 times as much money as it was, it's really going to be 8 times. Because if the data that you care about has to be there positively because it's so high performant and requires our business and blah, 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 then you got to buy 2 of them. Right? Because these things aren't running RAID, it's just memory. If you can use it as a cache, even though it's not shareable, if you move a workload to another server, it's still not shareable if it's just sitting in one PCI bus. But if it's running as a cache and not a fixed object, at least it can be leveraging that asset for all of the data connected to that particular physical machine. Closer you get to that processor, lowest latency. Lower the latency. Now, latency matters now in some, again, in a lot of applications. As a general application set, email, latency doesn't mean anything, right? Half of our stuff, file serving, we're in the cloud. What are you talking about latency? Right? So these vendors will have you believe, though, a lot of vendors will have you believe, no, 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 you have to have it, everything right in that PCI bus. It's all about latency. Really? I do PowerPoint. Shush. All right, so hey, look at I talked about that. The best case scenario for in the PCI bus is when you want it to be, if it's not going to be a cached, you have a known workload that requires super low latency, guaranteed performance levels. Simple as that. Anything that has transient data requirements, like Exchange, like all these sort of real-world office applications that we all run, they're actually not well suited for this. You want to take your indexes from Oracle, put them in there? OK, great. I buy that. You want to take the Oracle data itself? No. No, because it's transient. Things move every day. It's all brand new stuff. It's not a good application for that, irrespective of how some might lead you to believe. Anytime there's a transient workload, it's always best if you can think of it in terms of cache. If you can cache it, it's way better. You've got a much higher likelihood of being successful. All right. Some of the names. By the way, there are a million companies that you've never heard of in this business. And just like it shook out in, I pick your market here, 30 years ago there were 27 disk drive manufacturers. Now there's 1.5. Same stuff will happen. Half of these guys will go away. The big guys who make the components themselves will stay around. Right? Do you know who makes your DRAM chips? No, because you don't care. But it's Samsung or Toshiba or whoever, the big guys. Same thing will happen here. The value is not going to be in the hardware. It's never been in the hardware. Today it's marketed as that. But so all these guys, I don't know who wins at the end of the day. I don't care. Right? It's just going to continuously push down on the commodity curve. They will get volume capabilities. The other good part about flash, by the way, I should have mentioned earlier, is the reason it's got an accelerated decline in overall economic is because it's a consumer-oriented product. It's in your phone, right? They sell zillions of this stuff. So there's a lot of R&D development and a lot of really rapid deceleration of costing that's going to happen. I talked a little bit about, it's not confusing enough. We had tier 0. You're about to have tier -1. Because as soon as Intel embeds PCIe right into the core, now we have to come up with, oh, God, we got to shift everything. All right. Intel will be a player here, too. I don't know if I listed them. Second place we want to talk about where can you put it if it's outside of the server is we're going to put it in the network. If flash can execute as a network cache, right, it's one step removed from the PCIe bus, so it will have slightly higher latencies. 99% of the time, that's not going to matter. Right? And think about this. We have this infrastructure, in this example on file, we have this existing infrastructure out there already today. What if we could add a flash-based network cache into the environment that made everything that we already have from a share perspective and a file serving perspective go faster? Wouldn't that be good? I think that's good, right? These are just starting now, and there's two ways to do that. One is in-band, so it's a mount point, supersedes what you have. You mount that device or file system, and these are some examples of folks doing that. Good stuff. Then there's out-of-band, and so far I only know of this one cached IQ guy, meaning they're not a mount point. You don't even see it. It just automatic. You're still mounting the stuff that you already mounted. It just now suddenly goes faster. And that's pretty neat. How much flash and cache do you need? I don't know. Right? This provides outstanding economics because everything's shareable by everything when you're out in the network. Everything's shared by everything. Everything beneath it, everything above it can attack to it. So it's going to, by default, have much better economic impact potential, assuming that the algorithms work, assuming the right data moves up the stack when it's needed. Okay. Where else will it exist? There's a whole new subset of storage vendors now. EMC just bought one. And seriously, by the time I landed, they bought 2 companies. It's very annoying. They don't even think of me when they do it either, because every time they buy one of these companies, I lose a customer. It's not fair. Solid-state storage is a target. All flash arrays exists now. Cool. Without, and we'll talk about, they have existed for 35 years. You could buy a solid-state disk drive 35 years ago, I think, all built on DRAM. Right? So it's not necessarily new, but now all flash-based arrays, bunch of people doing this stuff, bunch of people. What's the benefit to that? Really fast thing. Fixed device, though. So once again, what's the fault in that? Only fault is you're the algorithm. You have to decide what data set goes on there. You better be right, because this stuff's expensive, comparatively. How we get around the cost? Because, by the way, remember, if money were no object, this is what you would do. This is what everyone would do. We wouldn't have disks. Okay? Think about this in your data center. What else is not solid-state technology? What is the only thing that is not solid-state technology in the data center? Storage. Only thing. Everything else has been solid-state for 20 years. Everything. We have the only mechanical things in our data center are air conditioners, one way or another, and disk drives. Eventually, we got to catch up. Anyway, the way that we go around and miss the economic devastation of being able to provide all flash arrays is through technologies. Compression, dedupe, whatever the optimization term du jour is for primary capacity, right, is a really interesting phenomenon here. Because if we can crush the economic negativity, instead of it being 10 times more expensive than a normal spinning disk array, if it was only twice as expensive, and God forbid, what if it was the same price, why would you buy disk drives? You wouldn't. You wouldn't. You would, but everybody else wouldn't. Some of you just don't believe. Okay, where else? Solid-state storage as an array component is what every one of you already have. Right? We have an array, and we're all of a sudden, whether it's a VMAX or pick your thing, you can add now flash-based solid-state storage as a target, a LUN, a device. You decide what goes on it. You can do that today. Right? And that's very popular. Everybody does that. We're adding an SSD inside an array we already have. Literally everybody has that now. So it's great for adding that high-performance tier inside a multi-tiered array. Negative again, you're the algorithm. You make the decision. You better be smart, because that stuff costs a lot. If it's cache inside that array, that's the smartest way to do it. And what I mean by that simply is the array itself has a bunch of tiers already in it. Whether you know it or not, it always has. Right? Because the array is a computer. The controller has processors that execute a command set or a whole bunch of command sets already. So it moves and sucks up data from wherever it is down below, whether it's on 12K RPM drives, 15K SATA, whatever the case is. Right? It already is doing all these types of things. So adding a cache component inside an array is basically that you're saying, I accept the automation. I accept that the machine is smarter to self-optimize within that array itself. And that's a good thing to do. You should release your anger. Let the machine do its thing. This is the cheapest way to make everything inside that expensive box go faster. There are purpose-built arrays now that you can't tier. There are others that have, so there's a whole slew of companies. Let me see if, yeah. Guys like this that built from the ground up, or Flash Cache, for example, from EMC. These others, they're companies that built from the ground up intelligence directly into the system that say, I'm going to put X percentage of the overall capacity, real or virtual capacity, of the array as flash and apply orchestration, caching, logic, and intelligence to it so that the entire array itself operates at a constantly optimized state. And so what they're guessing is that they can have 95% cache hits or something outrageous like that, some really high number, so that they can say, yeah, I don't do 1 million IOPS, but I do 900,000. And instead of it costing you 10 times as much, it costs you 1.2 times as much. And those are pretty good math economics right there. I still find it interesting that I think, I don't know what the real percentage is, but I'll totally make up a number. No. It's like only half of the people, even on the highest end VMAXs or HDSs or Sharks, right? The smartest, wow, crazy big high-end arrays that have so much intelligence and capabilities, only half of the users of these actually implement automation, let the machine do everything that it is capable of doing, which I find stunning. I really do. Turn it on and let it run. Anyway. All right, so where should Flash go? Yes, everywhere. Right? There are no binary decisions in what I just talked about. It will exist and does exist everywhere. Don't get hung up. Right? I guess the moral overall to this story is wherever you can put it, put it. Right? You could still, if you wanted, you could still ride a horse to work. It is a legitimate, valid means of transportation. You would be an ass, but you could do that. The reason you don't is because time moved on, right? There are better ways, there are more important things for you to do with your time and et cetera, et cetera. But that is still a valid mode of transportation. It's the same thing here. You could still buy disks, and you will for a long time, but sooner or later, you got to get over it. Right? You got to get over it and move on. Flash is going everywhere. So adopt, accept, and move on. Okay. The more solid-state stuff, the better. Solid-state stuff breaks less. Fact. Breaks less. Takes up less room, less real estate. Sooner or later, it will cost less. I don't know when. Sooner or later, it will cost less. It's just better. It's the reason, look, you could still have vacuum tubes in your computers, but you don't because it's dumb. Right? If HP could make more money selling you vacuum tubes, they would. We've evolved, but we haven't in storage yet anyway. So in a perfect world, here's some examples. In a perfect world, every server that you had would have 100% of the data it ever would need in Flash embedded right into the server itself. Money were no object, and we could defy the laws of physics. That's what you'd do. Everything would be 100% loaded up. So any instruction that had to be executed was always executing out of memory. Right? Perfect world. Not realistic whatsoever. Second best potential solution would be that Flash really became cheap really fast so we could just shove more and more and more into those servers. as we go, and then we would use that as cache within those servers themselves, and then we would have all of our data sitting on some solid state array. Everything in our shop would be completely solid state. And then we would feed it and serve it via caches to whatever transient workload was required on whatever physical server at the time. We're ways away from that. Third best is we go to the the same extreme that I just talked about, but we start to add network cache-based flash in order to make our existing data infrastructure move faster. This is real. This can be done today. Right? We're going to start to make all the things that we have move a little bit faster, or in many cases, a heck of a lot faster. What else does that do for us, by the way? We've made investments in existing infrastructure. We've already spent the money. We don't need to throw it out. We just need to make sure that it can support whatever our new workload requirements are. So by making it faster, that's probably good. Gives us more headroom. Actually adds life to existing decisions that we made to, as opposed to being forced to throw something out. Now we can extend its useful life, potentially, by adding a little bit more on top of it. The most realistic is that your world exists in all of these manifestations already. You have arrays that have no flash. You have some arrays that have fixed solid state capabilities inside of it. You have other arrays that have caching. Maybe there's a little bit of cache, maybe there's a lot of cache. Right? And then at some point you will have all flash-oriented stuff that you're going to add to the mix. But it's not one or the other. The answer is yes, it's just going to go everywhere. And we're going to add network caches. Have I made that point enough yet? Eventually it will consume more and more real estate, logical real estate, in all of your devices. Eventually. You guys are smart to ask that question. God. No flash is no good. So this is not a technology. Most technologies that come out in our space are way overhyped, way too advanced. And our advice to an end user would always be, you know what, just hold on. Let's just wait and see how this shakes out. This is not new. And so the natural reticence of a buying market, I understand. Flash is not something you should wait on. Flash is only going to help you. So the questions around vendor A versus vendor B, whether you're talking about storage, whether you're talking about networking, whether you're talking about servers, I don't care. Whether you're talking about applications, whether you're talking about the cloud, the question should be, how are you implementing Flash? Or a question should be, how are you implementing Flash to best serve whatever mission you're on, Mr. Vendor? Because if they don't have a good answer in this area, they don't know what they're doing. They're milking whatever the life that they lived, because this is where the world is going to go. Don't listen to any of this. Mine's bigger than yours. You don't care. Don't get hung up on hardware. And I'm going to talk a little bit more about that specifically, but don't get hung up on the MLC, SLC, this chip, that chip, stuff like that. That stuff will be completely commoditized exactly the way DRAM has been commoditized. Right now, vendors think it's a differentiation for them, but it won't be, and it shouldn't be. The whole key to all of this stuff, because Flash is going to exist or does exist already in every point, every bump of the wire within your data center and your virtual data center, is the whole value proposition, all the money that's going to be made in this particular market is going to be made by orchestrating the data layer. It's not about the board or the chips or any of that stuff. It's all about who can best optimize and orchestrate the data from wherever it is to where it needs to be. You do that, that's the magic keys to the kingdom. We'll talk a little bit more about that. Until we reach that pinnacle of life in IT, where every single piece of data sits in every single server and we don't have to move anything ever anywhere, there's going to be tiers. Right? We don't have one tier. Within that, we have tape, we have disk, we have cloud, we have 57 different tiers of disk, blah, blah, blah. There's always, as long as there are tiers, orchestration becomes the key. What I want you to start to think about, today we talk about data orchestration and cache in the context of a box. My system, my subsystem, does all sorts of magic things, moves things around. You're going to lose the notion of the box. This is hard, but the individual discrete components already do this stuff. The real value is between the boxes. That's hard. No one's built an algorithm yet that says I can do data orchestration or caching between all of these boxes. My stuff, your stuff, somebody else's stuff. The network, the servers, that's really, I'll picture it, hope that makes sense. We talked about the basis of intelligence in caching as letting the machine figure out what you need when, putting it exactly where it's supposed to be, and hoping that it's such a good algorithm that we're right way more often than we're wrong. If that's the case, fantastic, right? Extend that concept outside of the four walls of the box into the four walls of the data center. Then extend that concept outside of the data center, because we are all global one way or another. Complicated, difficult stuff, for sure, way more value associated to that than my chip's faster than your chip. Way more value. I have no idea what this graphic was supposed to mean. I'm not going to lie to you. The one with flash goes faster. Thank you. I knew it when I did it, but seriously, I have no idea what that was supposed to mean. All right, so this world, if you're 100% flash, it's as fast as you're going to go. It's just where are you going to put it. It doesn't get any faster. If your data sits on 100% flash, whether it's in the PCI bus or in this example as a subsystem, fast as it's going to go, right? Second element is, can you use flash as a cache within that subsystem and throughout? If that's got the solid algorithm, it's the second best thing you could ever do. Third is, I'm going to shove solid state disks into an array, and I'm going to be the arbiter. I'm going to decide what goes on those disks and hope that you are right. And then, of course, the worst element is there is no flash. There is no intelligence into that. Most of the world lives in that world right now. And we shall evolve. Adding network caches into that same picture, right, where we already have everything. And now you get the kind of example of not only is it not binary, but flash technologies exist at every bump of the wire, every point. Right? That's okay. So when I talk about what's the most important thing in all of this, it's not flash in box 1 versus flash box 7. It's about how does this whole thing work within the context of my data center? Because guess what? I run virtualization, and those workloads are moving, and they're changing, and the nature of things are changing. Here's the other problem that we have, that's the natural enemy of IT. All the technologies exist to solve all of our problems within IT if data growth stopped. If nothing changed, if we knew exactly what the state of the union is, you could fix every problem. Right? We have. The good news for this industry is that never happens, because data growth never abates. And at some point in time, no matter what your process, no matter what your application, no matter what the physical attributes that you deal with, data growth will break everything in IT. It will break your backup. It'll break this. It'll break that. It'll break. It's the only true known thing. You know, it's why it's such a great business. The storage business is recession-proof. No one ever needs less. It's just a matter of how much more. Right? How much more and at what point, and how are you going to solve that? So this stuff is not going to get easier for you, is my point. It's going to get harder and more complicated, because we can't even fathom what the next crazy use case is going to be. No one could have predicted that the cell phone was not going to be a phone anymore, right? That it was just going to be some sort of object that helped me create content instantaneously, transmit content throughout the world, all over the place, and we're going to type with 2 thumbs and create a whole new language. Nobody could predict that. And what does that mean? Right? What did that mean for bandwidth and all these other elements? So attempting to predict what your businesses are going to want to do with their IT assets in 5 years is nuts. All you can do is try and make sure that you can build an infrastructure capable of supporting whatever those requirements are. Sometimes they'll be loony, and other times they'll be brilliant, but we don't know. And so trying to predict the future in terms of use cases has proven to be a crazy fool's errand. The only thing that we can try and build for is an environment that can be orchestrated. If you're going to orchestrate appropriate data placement, right? We talked about caching. If it's just within one box, that in of itself is a challenging thing to do. When it's outside of the box, when we're orchestrating data placement throughout our data center, not just a box, that's really challenging. And that's the highest level of value, I think, that infrastructurally can be associated in any of this whole business. And there's crazy $100 billion a year spend. This is where all the money and value is going to be created in the next generation. The gate to orchestration is not about the caching technologies, per se. The gate really is the human being. The gate is you have to embrace and accept automation because you cannot. Right? It's hard enough for you to take a 3-tiered subsystem and manually decide this data set goes on tier 1, this goes on tier 2, this goes on tier 3. That's hard for you to do today. How can you possibly do it when when there's no box, when everything is just virtual, when it's got to be between boxes and between servers and between network channels, et cetera? You can't. You have to embrace automation in order for any of this stuff to work. You can ride a horse to work, right? But you'd be an ass. You got to let these boxes. Now, by the way, industry's challenge is now I'm going between boxes. And so that's a hard thing for them to do, because guess what? Not every box is EMCs. Not every box is NetApp or whatever, right? The real worlds in which we live in have all sorts of stuff in there. And to be able to embrace that and control the automation layer and appropriate data placement throughout our data center and then ultimately throughout our virtual data centers is really, really, really compelling. But it cannot happen if you decide, nope, I want to know what goes there. Because you will slow everything down and you'll screw it up. And I love you. I don't want you to get fired. I'd have to get a real job. We worry about this stuff in the box, out of the box, in the data center, right? We want to automate the data placement of the data center and of the enterprise and of our company, whether or not it's our data center or not. Flash will exist in all these places to enable the performance we need for this to happen, but Flash isn't the answer in and of itself. The answer is at a higher level orchestration layer, caching layer, for lack of a better term, but it's optimized data placement irrespective of the boxes where all this stuff's going to happen. So, I can't believe I'm on time, too. Flash is not yes or no. Flash is only yes. Just say yes. Accept, believe. It will make the individual things that you do better, and ultimately, collectively, it is mandatory to make everything sort of work cohesively. You should start now if you haven't. Even if you think you haven't, you have. It already exists in your world one way or another. But accept it. Right? Understand from your vendors, I think it's important, and it's very telling, what is that vendor's strategy for Flash? And I don't care if you're talking about server, storage, or other. What is that vendor's strategy? Because if they don't have something they can articulate to you that makes sense to you, you should be questioning that vendor. Accept automation, my brothers. Okay. And so with that, I do want to say thank you. You can get, I want to thank EMC again. They also, by the way, have done you a tremendous favor. And they are sponsoring, they've paid for you to have 6 months of access to all ESG's content there. You get that for Zippo, just because for being an EMC World attendee, so I think that's terrific. You can get a copy of this presentation, copy of, we've got a 25-page, very detailed market landscape report on this whole flash market that gives far more detail than you may ever want, but at least it's there for you. That stuff's all free to you. Excuse me, well. And because I'm on my Vanity 2012 tour, follow me immediately on Twitter. Very important to me. I only care about what people think. No, but do it anyway, because that'd be good. I do want to thank my good friend. Did you like the Vince Wilfork commercial? That was awesome. FCOE is bullshit. The big man. Sorry to all the foreigners, by the way, who have no idea who that giant solar eclipse of a human being was. The funny thing is, I'll tell you a quick story. He did that all by himself. He's a friend of mine, and he thinks that's what IT people dress like. And now the fact that he owned that outfit was a whole different thing, but anyway, thanks to both of those guys for being good sports on this. So thank you very much. I appreciate it, and I hope you had a good show. All right, take care.